Any improvement in your CAM programming efficiency can reduce the time it takes to get your parts on your machines, helping to increase the profitability of your projects, which is why Autodesk PowerMill 2023 has undergone a number of performance improvements to speed up your part programming. In this tutorial, we will be looking at two different performance improvements. The first will look at curve projection toolpath calculation, and the second will look at the generation of a spun profile. In both examples, we will be making a side-by-side comparison between PowerMill 2023 and PowerMill 2022.1.1. In all instances, both versions will be run on the same Lenovo ThinkPad P71 workstation laptop, which has a quad-core Intel Xeon E3 processor, 64GB of RAM, and an NVIDIA Quadro P4000 graphics card. Starting with curve projection, this strategy has undergone a major update to the calculation algorithm to take advantage of multi-core and multi-threaded processors. And it is from this change that we see a significant improvement in overall calculation times. In this example, we will be looking at the simplest case of a curve projection toolpath, that being a straight line down the centre of this bottle mould, which has overall stock dimensions of 330mm in X by 180mm in Y by 75mm in Z. This toolpath also has the addition of a tool axis from another straight line curve offset in the Z direction. Here we have both versions of PowerMill, with version 2022.1.1 on the left and version 2023 on the right. In both cases, we will access the toolpath settings form of the From Curve Semi-Finished toolpath in the G54 setup and simply hit the Calculate button. Using the CPU utilization monitor in the Task Manager, we can see the difference, with PowerMill 2023 peaking at 100% usage. Notice how PowerMill 2023 finishes the same calculation much faster than PowerMill 2022.1.1. Summarizing the results, in this test we can see that PowerMill 2022.1.1 took 22.8 seconds to complete the calculation, whereas PowerMill 2023 took just 15.2 seconds, an improvement of 7.6 seconds, saving 33% overall. Moving on to the second example, the generation of spun profiles, which are primarily for turning feature creation, has been sped up too. In this example, we will be looking at creating the spun profile needed for this mill turn part, which is 260mm long, with an overall outside diameter of approximately 180mm and an inside diameter of 95mm, with the stop material oversized to fit the whole component. Again, we have both versions of PowerMill now displayed, with version 2022.1.1 on the left and version 2023 on the right. Since we want to generate a spun profile from selected surfaces, in both cases we will hide the 3-jaw chuck clamps level and switch to the front view. The aim is to create a turned profile feature. So we will create our spun profile by accessing the curve editor through the feature editor. So we will right-click on the OD Turn feature group and select the feature editor option. As we want a turned profile, we will select that option from the toolbar and then select the Create a Spun Profile button. In the Spun Profile dialog, we will change the mode to Surface Selection, drop the tolerance to 0.005, and then select all the part surfaces in the graphics window. We'll then hit the Create button to generate the whole profile. Notice how much quicker PowerMill 2023 calculates the profile when compared to PowerMill 2022.1.1, letting us move on to curve editing and feature creation much quicker. Summarizing the results, in this test, we can see that PowerMill 2022.1.1 took 20.8 seconds to generate the profile, whereas PowerMill 2023 took just 8.2 seconds, an improvement of 12.6 seconds, saving 61% overall. This speed improvement greatly reduces the time it takes to derive curves for turning features. And with more updates like this which speed up your part programming, Autodesk PowerMill will help you get your parts on your machines even quicker.